Well, this is review number 5, and I'm going to go over the general idea, but I'm not going to do all of the details. So this is basically for those people that have had difficulty with review number 5 and want to at least get partial credit on this. So first of all, chapters 7 and 8. So chapter 7 is about confidence intervals. So if it says something about interval, that's talking about chapter 7. And then chapter 8 is hypothesis testing. So if it says something about test a claim, that's from chapter 8. So that's the first thing to do, is identify. For example, here this one is saying test the claim, and then it's the mean. So the claim would be that the mean is equal to 100, and then you would write down the h sub 1 and the h sub o. So I'll leave that for you to do. The next thing to do is the question is about the IQ scores. So you go to the data over here and you type the IQ scores into the calculator and then find the mean and standard deviation. So then you'd write down that information. N equals 25 people. The average IQ is 114 point something, and the standard deviation, like I say, please find that with your calculator. Then draw the bell-shaped curve, and this one is going to be a two-tails test. So using 95% level of confidence means we have this, which is 0.025 for this tail and 0.025 for this tail. And when it's about the mean, you use table 8.3. And degrees of freedom would be n minus 1, so that would be 24. So if I go to the table and use degrees of freedom 24, so this was a two-tailed test, and for those two tails it's 0.05, so you'd use this middle column, and then degrees of freedom is 24. So 2.064 is the critical value. And then on the left it would be negative 2.064. And then you could do the T-test on the calculator and find out what the test statistic is. So if the test statistic lands over here on the right, or in other words past the 2.064, or if it lands over here, that means you actually did prove something. If it lands in the middle, then we're not able to make a conclusion. The evidence is not strong enough to prove anything. Okay, then on to the next one. So first of all, right here, it's got the word interval, so that means that's chapter 7. And when it's a proportion, you don't need that much information. You need to know what is the sample size, 25, and then you need to know how many successes are there, that's x. So now you just go and count how many people have at least a 3.0. So that means 3.0 or above. So then you would just scroll over here to the data and then just count how many people have at least a 3.0. So once you finish counting that, that's going to be x. So x equals whatever you get, put that right here. And then the p-hat is when you divide those two, x divided by the sample size. And with a confidence interval, you can have the calculator do that. So that would be 1 proportion z interval. And then you just need to tell the calculator what's n, what's x, and that you're using 95% confidence. And then the final answer would be that p is between this number and this number. On to number 3. So it says test, so that means chapter 8, which means you need to write down the claim, and the claim is about the mean. And then the word at least 3.0 means bigger than or equal to. So the claim is that the mean is bigger than or equal to. And then write down h sub 1 and write down h sub o. And then since this is about the GPA, you would go to the list, put the GPAs in a list, say list 2, find the mean and standard deviation. And so you'd say n equals 25 people. Their average GPA turns out to be 3 point something. And the standard deviation, find that from the calculator. And like number 1, you would then draw the bell-shaped curve. This one is going to be a left-tailed test. So this is 98% confidence. This is going to be 0.02. And then use table A3. Degrees of freedom is still 24. So if I go over to the table, this one is just a one-tailed test, and we're using 0.02. Well, they don't have 0.02, but they have this one, 0.025. So you'd use the middle column. Turns out it would be the same critical value, except it would be negative because it's a left-tailed test. And then, like number 1, you could do the T-test on the calculator, and you would get the test statistic. So if it lands over here, that means you actually did prove something. And if it lands over here, that means that we did not prove anything. And then write the conclusion. Then for the interval, so that's chapter 7. Find the interval for the mean GPA. So right here, you just found the information that you need for this one. You should still write it down. Here's the information that I found for their GPAs. And then you can use the let me look on the calculator. Stat, tests, and then T interval. So number 8, the T interval, and you type in the information. So then you could use the T interval, and then it's going to say that their mean GPA is between this and this. And then answer this question. Does it seem likely that their GPA is, or in other words, equals 3.0? So if you get something like their GPA is between 2.7 and 2.9, which is not realistic, I'm just making that up. But if that was the case, then I would say, no, their GPA is not 3.0, it's actually less than 3.0. So basically just see, does it seem likely that it equals a 3.0 after you get this interval? Then on to the most challenging question. The reason it's challenging is because first you have to divide the data, those that have under a 110 IQ, and those with at least bigger than or equal to a 110 IQ. So I go over to the data, and then first of all I'm going to look at this group, the ones that are less than 110. So let me just erase these marks. Okay, so those that are less than a 110 IQ, and then I'm going to highlight them all the way across, and less than 110, 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 less than, less than, less than. Okay, now the actual question was about their GPAs. That's why I was saying this one is a little bit more challenging, because right here it's talking about what's their average GPA. So now what you need to do is, for all of these GPAs, you need to put them in a list. So all the ones that have been highlighted yellow, you put their GPAs in a list, and then you find the average GPA. Then for all the ones that have not been highlighted, you put them in a different list, their GPAs, put those in a different list, and find the mean and standard deviation. So then you put that information over here. So for those with less than a 110 IQ, here's how many people there were, here's their average GPA, and here's their standard deviation. So this needs to be a GPA. So if this right here says something like 109.7, then you type the wrong data, because there's nobody that has a GPA of 109.7. So this instead should say something like 3.1 or something like that, something which that could be a GPA. So you do that for the two groups. So for the other one, you had their GPAs in a list, so you write down the sample size, what's their average GPA, and what's the standard deviation. And then you can use the t-interval, like this one, on each one. So then for this one, their average GPA is between this number and this number. And then do the same thing for this group. And then based on that, you just see, does one stand out as having a bigger GPA? So when you're comparing these two intervals, does one interval look like it's got higher GPA than the other? Then for the next one, confidence interval, so that's chapter 7. And you're using the same two groups. So you would still have those less than 110 IQ and those with at least 110 IQ. So the n's would be the same as right above. So you'd still use this n and this n. And since it's about proportions, you then need to go and count x equals how many successes for this group, x equals how many successes for this group. And a success is if they have at least a 3.0, so bigger than or equal to 3.0. So for this group right here, those are the ones that I had highlighted in yellow. Then I need to count how many have at least a 3.0. So with the yellow ones, at least a 3.0 would be this one, this one, this one. Keep in mind only looking at the yellow ones. This one. And that looks like it's it for the yellow highlighted ones. So for the red marks, that's 1, 2, 3, 4. So then you'd go back over here and say this question mark is equal to a 4. And then you would go and count for the other group how many. And then you would use the 1 proportion z-interval for each group, and you would find out what's the confidence interval for their percentage and what's the confidence interval for their percentage. And that one would be done because they didn't ask for a further explanation. And then finally, a general explanation. So most likely, this one will help you do the general explanation, because that's where you're really comparing the two groups in the most straightforward manner. And last, when you make a confidence interval, what you do is you have a sample mean. And then you find the error and you add the error on to get the number that's on the right side. you subtract the error to get the number that is on the left side. So that is this number, this is that number, and then this right here, the best point estimate, is saying, what does x bar equal? So in other words, what's the number that's in the middle of those two numbers, 84.1 and 96.3, just whatever's in the middle. Hope this helps, and email me if you have any questions.